So in today's video, we're going to be talking about a very specific kind of function. So we talked about functions last time, and we touched on the topic of a recursive function. So I want to go into more depth about what that is. But before we talk about recursive functions, there's a very important concept that you need to understand, and it's a concept of a stack. So here in front of you, I have a stack of books, as you can see. Now, a stack in computer science is essentially just a data structure. It's a way of holding data or objects in a convenient way. So if you have a stack of books, we put the books on the stack in the order of green, red, and then the brown book. So that's the order that we put the books on. It goes up. But the order that we would take the books off of the stack is we would actually take the brown book off first, the red book off second, and the green book off last. So the first object added to the stack is taken off of the stack last. Or to put it another way, the last object is taken off first. And this is very important, because whenever you're programming or you're running a program, there's something called the function stack, which holds function calls. And we talked about what a function call is. It's essentially when you call a function, that piece of code is going to execute. However, sometimes functions have other functions inside of them. And so what do we do about that? Well, we want to execute the inner functions first, right? So what we'll do is we'll put the functions in a stack, and whenever a function is called, it goes onto the top of the stack. So this is how we would handle that right here. So now we know what the stack is. I'm going to tell you what a recursive function is. A recursive function is a function that calls itself. The classic example would be a factorial function. So n factorial, let's say n is a number, equals n times n minus 1 times n minus 2. We keep going until we get times 1. This is n factorial. We can implement this as a recursive function. And here we can see that whenever we do this, no matter how big n becomes, we'll always get down to 1. Now this is a very important idea, because 1 in this instance is what we call a base case. Base case. In recursive programming, the reason that the function can work is because if you have a function that all it does is call itself and nothing else, we'll get what we call a stack overflow, which is where the popular website gets its name from. So you can imagine the stack kind of like a glass of water. In each function call takes up a little bit of space inside the stack. So we call this function, and so it calls this function, and we keep going. But if we call too many functions, your computer can't store all of these in its memory, and we get what we call a stack overflow. We can't put any more functions in there, but because we can't call any more functions, we can't actually evaluate the first function, which means we just get this error and the computer program is going to crash and everything's very bad. Stack overflow is not the ideal. So we have a base case so that eventually you'll stop calling a function and you'll get an actual answer. And when that happens, that answer is sort of propagated down to the first call. Now what do I mean by that? Well, we could define factorial n as n times factorial of n minus 1. And we could keep doing this for all of our n's until we get n equals 1, in which case we would just evaluate it to 1. We could sort of imagine this as a graph. So you can imagine this is, factorial n, and then it calls factorial n minus 1, and then these keep going and going until we get to factorial 1. And this will stop calling things. This will give you an answer, 1. And so then we can plug 1 back into n minus 2 here. So now we have an answer here. And we can plug this answer back into the previous Just keep going all the way down. This answer propagates down to n. And that's a very important concept. However, it doesn't have to propagate downwards. Sometimes we get a recursive function that does not have necessarily a value that's returning. So we can see that demonstrated quite nicely in a function like this. Imagine you wanted to implement a fill tool, sort of like you see in MS Paint. How would you do that? You would select some color, presumably, and then you would change all of the adjacent pixels of that same color to a new color. So let's say we wanted to change all of these red pixels here, but the red pixels are in a little bit of a strange shape. It's not obvious how we would change the color for an arbitrary shape of red. Well, we can actually do this recursively. And what we do is we would pick an initial spot. Let's say we pick this guy right here. And then if it equals red, which it does, we would change it to some new color. But then, and the important part is that the function would call itself. And the way it would do that is it would essentially look at its neighbors and call the function to all of its neighbors. So now we have this function being called to all of the neighbors. Now, if the neighbor equals red, it's going to do the same. It's going to change its color, and it's going to call all of its neighbors. So the function is calling itself, but it is evaluating, because it's not actually evaluating to any numeric value. It's just essentially executing a piece of code. You can imagine that you would keep going and going and going with this. And, it would look something like this. So that's the general idea of recursion. Is that you can have a function that calls itself, but that also has a base case and can evaluate. So in this example, the base case would be when the color is not the same. In this case, the color is not red, it's white. And so that's our base case. We're not going to do anything. Similarly, you might, call in the same direction, but this is no longer red, and that's a base case, so we're not going to do anything. So that's the general idea of recursion. A function that calls itself creates this sort of graph of functions on the call stack. Eventually, it will be evaluated, and then that answer could propagate back down if you're trying to return a specific answer. Or in this case, if you're not returning an answer, it could simply just execute a piece of code depending on some condition. So that's the